Hi, today I'm in conversation with Paul Denny, a lecturer from the University of Auckland and an active researcher in the field of computer science education. Many students and teachers will be familiar with his award-winning Peerwise collaborative education platform. We'll hear more about that in a moment. So Paul, welcome and thanks for joining us.
I'm very excited. Thanks for the opportunity.
No, I'm really excited. I think there's a lot of stuff that we can talk about. And the first thing I'd like to just talk about is Peerwise, which is the software tool that we sort of cross paths on first of all. So obviously I know a lot about it in terms of, I've been an avid user of it in my teaching days. So maybe you can sort of talk about what it is and how it came about.
Yeah, sure. So Peerwise is, at its simplest, is just a website where students create and publish practice questions, which other students can then use, particularly when they're preparing for tests and exams and so on. And yeah, if I think back to kind of where it started, there were a couple of kind of motivating reasons, but one of those actually was feedback that I got from my students on my teaching. And I'm sure you remember this, Bryn. At the end of the semester, you'd ask students, what did you like most? What improvements would you like to see? And one of the most common types of feedback that I'd see on those sort of end of semester evaluations was, we would like more opportunities to practice. So could you please provide, example exam questions, more opportunities to get feedback? And so certainly there was this desire amongst the classes I was teaching to have opportunities for practicing. And so for me, it was, well, how can I provide students with lots and lots of questions that they can use for practice? One way, of course, was just to point them to old exams. And I think a lot of people do that, right? Have a look at last year's exam. But trying to provide a very large repository of practice questions seemed like a difficult task for me because my time was spent writing the actual test and the actual exam. And so that was certainly one of the motivations, the fact that students wanted these practice questions, and it seemed like an interesting idea to get students to be the creators of those practice questions. It might be worth pointing out that there had been quite a shift in sort of paradigms around the way that people were accessing content. Right? If you look at right throughout the 2000s, there was this shift towards like Web 2.0 or user-generated content. Now, of course, all of our students are completely familiar with the fact that the content they see online is produced by other users of these systems, Instagram or Facebook or TikTok these days. And so I think it became much easier to do this type of what we might call a crowdsourced or a learner-sourced activity, because students could see the value in this model, where as long as you have a lot of individual users, each making a small contribution towards some resource, then that resource can become really useful. And so that was really, the initial idea was just students wanted opportunities to practice, and it seemed like an interesting idea to get students to create those practice questions for each other.
So I suppose that leads to the next question of, how effective has it been? Certainly, I know that it seemed like a good engagement tool in terms of actually getting students to participate by both writing and answering questions. Do you think that that's actually then led to better learning?
Yeah, that's a really good question. And I think when teachers or instructors are thinking about, is something like Peerwise, or I guess any other kind of learner-sourced activity, is this something I should use? The question of kind of learning comes up, right? If I'm going to expect my students to engage in this task, I'd like there to be some evidence that it's actually going to be useful to them. And so, yeah, in terms of, you mentioned there, Bryn, you mentioned the idea of engagement. So it's quite a good way of getting students to engage. And I think that's certainly one piece of it, which is that we want students to, read their lecture notes and review what we're teaching them. And it's always a struggle to get students to do that. And I think what Peerwise provides is a very simple and familiar type of task. Students are familiar with multiple choice questions where they can just review what they've been learning maybe over the last week. And so, yeah, in terms of just getting students to engage with content, it's a very easy thing for instructors to say, hey, I want you to create a practice question that targets some of the material we've been talking about over the last week. And so I do think that it's very good, in terms of, just getting students to engage with content. But yeah, the big question is, what evidence is there that actually students really benefit from this above just engaging with their content? And I guess actually that leads nicely into one of the other motivators behind creating Peerwise, was that there are these very robust phenomena from the educational psychology literature, so things like the generation effect, for example. And we know that people remember information better when they take an active role in producing that information. I think this effect really underpins all of the sort of active learning type activities that you might use in a class, right? We don't want students just to sit there passively listening to lectures. We want them to actually do something and create something. And so that generation aspect is very important. And so if you think about sort of something like Peerwise, students are creating these practice questions, multiple choice questions in the case of Peerwise. And so they're going through this generative activity, right? They're looking at their content, they're bringing together ideas, and they are creating this artifact, which sort of summarizes their understanding of that particular topic that the question targets. So there's the generation aspect. And then I think relating closely to what students were saying about wanting opportunities to practice, there's a very robust phenomenon known as the testing effect, which says that being tested on previously studied material is a very powerful way of remembering that studied information. And so, of course, Peerwise provides lots of opportunities for students to practice by answering the questions that have been published by other students. And there has been a lot of research looking at trying to measure the learning effects of this type of activity. And one of the papers which I really like, it was published by a group of researchers from the US, and it was in a psychology classroom actually. And what they did was they looked at the questions that students generated when they were using Peerwise, and they looked at the questions that students answered for practice when they were using Peerwise. And then they looked at the actual exam questions, so the questions that appeared on the final exam. And they were able to answer questions like, if students were creating or generating questions on a particular topic, how well did they perform on the final exam on questions that targeted that same topic? Mm. And likewise, if they were answering questions, practicing answering questions on certain topics, how well did they perform on the exam on those topics, compared to students who weren't generating or answering questions on those topics. And I think that it was a really nice article, but the kind of takeaway for me from that study was that the generation activity is more effective, but less efficient than the testing activity. Mm. And so what I mean by this is that, when students are creating questions, it's very powerful in terms of the learning effect. Students who create questions on a particular topic drastically outperform students who don't create questions on that topic. However, it takes a lot more time to create a question, and that time on task might be a big reason for that effect. And so students can only create a certain number of questions. They can only cover so many topics in the time they have available to create questions. On the other hand, students love answering questions for practice, and they can cover many more topics in doing so. And so from memory, the effect sizes were something like a 15% increase based on generating content, and something like a 5% increase based on practice testing, but students covered many more topics, so it was more efficient to do the practice testing.
So one of the things I think is always interesting about this is, so Peerwise is just multiple choice questions, and normally when you think about multiple choice question in terms of its educational quality, if you go to sort of Bloom's taxonomy, traditionally multiple choices right down at the bottom. Yep. In terms of just almost at the recall level, and the interesting thing is that by creating a multiple choice question instead, well, then that gets you right up to the top in terms of actually that creative aspect. Mm. And one thing that we've both looked at, I think, is whether we can get anywhere in the middle region of that Bloom's taxonomy to sort of more the analytical aspects. Do you see much evidence of that in at least the course you've used it in?
I think, yeah, so certainly the creating content is up at the higher levels of that taxonomy. There are other activities that students engage with within Peerwise that I think might fall in those middle levels. So things like, for example, making judgments about the quality of the content that they see, right? So when a student answers a question, even if that question is simply a recall level question, they still have to make some judgment about the quality of the question. How relevant is it? Was it well worded? Were the distractors plausible? And they then provide a score, and they can also provide some commentary about the quality of that question. And I think that sort of an activity brings in some of those, skills of analysis that fall more into the middle ranges of the Bloom's taxonomy. And so I think, it's been fascinating to me to see students publishing questions which might have an error, and then to look at how effective other students are at detecting those errors and correcting them. And in fact, there has been papers on looking at this. What's the rate of what proportion of questions in a typical repository created by students have errors, and how effective are other students at detecting those? Yeah.
Well, that was one of the things that has always interested me in terms of trying to get students to actually engage with that. One of the things that works against it is that students may they feel like, well, if another student has written this question, then how much do I trust it to be true? If you're wanting more questions to attempt, you want them to be, the answers to be the right answers and things. And one of the things that I think we ended up having to do when we tried to use it as an activity in some of my classes was I had to get a tutor to evaluate the correctness, as much to encourage the students to believe in the answer as anything else. But it's still been a very popular system. I mean, you've had that running for several years, and you've won at least one award. Is that right?
Yes. So in terms of sort of breadth of use, I mean, look, I've been involved, Bryn, in lots of projects which never see the outside of my classroom. Like there are ideas that I have, and they just don't take off. So Peerwise has been quite successful in terms of breadth of use, and I guess there are various metrics that you can look at, but probably the one that I'm most proud of actually is around the research activity around Peerwise. So when researchers, when teachers use Peerwise, and whether they themselves are the researchers or they're working with educational researchers, they can access a lot of fine-grained data about student activity within the tool. And there have been something like 200 authors of papers that have used data that's come out of Peerwise. And so that's something that it's been really satisfying for me to see that, because of course my personal interest began in computer science and the courses I was teaching. And so I had done a little bit of work and published some work looking at some of these questions, like, what are the learning effects? What's the sort of typical quality of a repository, but only in my subject area. And so it's been really satisfying to see a lot of that work replicated across other disciplines, primarily STEM disciplines, but, chemistry, physics, and so on, biology. And so now you can look at questions like, what are the learning effects? And you can actually look at them across various disciplines. And so, yeah, it's been really nice to see this sort of community of researchers make use of the data that's coming out of the tool. The other sort of metric is the number of institutions in which it's been used. And one thing I always hoped was that it would be very easy for an individual teacher to make use of Peerwise without needing any kind of like institutional support, without having to get, some technical advice or to run a server at their institution. And so there have been just about 3,000 institutions around the world that have used it to some extent. And of course, in some cases, that can mean that at a particular institution, there are lots of courses using it. And at other places, it's like one single teacher at, maybe some small community college somewhere in the United States or in Europe or somewhere, and they've just used it with their own cohort of students. And so yeah, there are various metrics there. There are a lot of questions now, I think approaching 6 million questions covering, basically any subject matter you can imagine. And so, yeah, so that's been quite neat. And you mentioned this award, and it was in 2019, it was the end of 2018. It was called the QS Reimagine Education Award. And QS is this company which is very well known for producing university rankings. So they rank the universities, and they also have this Reimagine Education Award program where essentially people running projects can submit portfolios of their work for this competition, essentially. And I was lucky enough to go along to the event at the end of 2018, and it was just fantastic. Such an energetic community, in some sense similar to an academic conference where a lot of people get together and present their research, but different in that people weren't presenting necessarily empirical evidence of what they had done, but they were just presenting these wonderful ideas, tools that they'd built, or innovations they were trying. And so it had this real great energy to it. And I remember just feeling very excited about being around all of these other people who were building these educational tools, and I really learned a lot from it. But it was very surprising, but I was very excited to actually win the overall award at that conference. And I do think that, look, I'm very grateful to, I mentioned before, the community of educational researchers around the tool, because I think one of the criteria for the award was evidence of impact. And I think looking at the many articles that have been published across many different disciplines was sort of, I think, one of the areas in which Peerwise was particularly strong. It's difficult to sort of get that quantity of evidence across disciplines like that. So yeah, it was very satisfying, and I'm very grateful to QS for that opportunity to present my work there.
Well, I mean, I know that that's not the only thing you've been busy with. I mean, Peerwise has been your baby for a few years, but I know that you have more recent research in other areas, error messages being one of them. So tell me where you are with that.
Yeah, so I think one of the courses I teach a lot is an introductory programming course. In fact, I teach courses for engineering students and computer science students, and many students coming into these courses are novices when it comes to programming. And I think it's pretty widely known that for new students to programming, error messages can be particularly unhelpful in a lot of languages. I think we all, as more familiar or as experts, we have our favorite kind of error messages where we can just point at it and say, how on earth is that a good error message for this particular error, right? And I think to us, it's kind of a little bit funny, but to novices, who are really trying to learn and become familiar with a language for the first time, it can be extremely difficult to try to make sense of these cryptic error messages that they really need help from. I think, experts can draw on their just familiarity and experience with the language, and even if the message is not particularly helpful, they can kind of work out what's going wrong, but it can be very difficult for novices. And so that's, yeah, it's an area I've been very interested in. And my interest in that actually grew from a separate project I was working on, which was essentially an online programming tool. You might think of it like an automated assessment tool, but the key idea was that it was web-based, so students could practice writing code in their web browser, which is quite handy for like the first couple of weeks of a course, so that you don't have to worry about students, configuring their environments, getting set up with their tools and so on. And so it was a tool where students could answer these programming exercises in the browser. And it really opened my eyes, because it was the first time that we could actually see, by looking at the log files, exactly what type of problems students were encountering. I think, anecdotally, we knew that students found error messages difficult, right? You might go into the lab and see some student with their hand up trying to work out, how to resolve this error message. But often that evidence was sort of anecdotal. But now we could see over a large course, maybe several hundred or even up to 1,000 students, you could actually look at exactly what error messages they were encountering, exactly how much difficulty they were having resolving those error messages. And so this just became fascinating to me. And I think the individual case that really stood out to me was this one student who was attempting, I think, what we would consider a fairly basic type of task, probably something like computing the sum of a list of numbers or something like that. And they spent over an hour, and we could look at the logs and plot every action they made, trying to resubmit their code, get this error message or set of error messages back again. And it was over a period of an hour that they were not able to resolve what was really just a couple of fairly basic errors in their code. And so that just raised the question, first of all, were they reading the error messages? Is the error message actually something they're looking at, but they're just not getting help from? But really the key idea was, how can we help students like that? We don't want students to be spending an hour trying to get rid of these basic errors. Because, the interesting part of computer science is sort of the logic and how do you construct your algorithms and solve the problem. We don't want students to be, suffering, trying to, fix up these errors. And so that was really where I think my interest in error messages came from, is just suddenly being able to see very clearly the extent of the trouble that students were having with them.
I think that's one of the interesting things that I've seen elsewhere. Amy J. Coe has done some work in treating the interpreter as representing the interpreter as a character, and allowing the user to realize that they're almost in a conversation with this other entity, and you're communicating stuff, and it's just not understanding quite what you're saying. And I think that often helps the student to understand that there's no magic here. This thing is, you told it to do something, it's trying to follow the letter of what you said.
Yep.
And then it gets stuck. So I can see the value, particularly for an early learner. One of the other things that was mentioned in a previous interview when I had with Rebecca Yang, she made this interesting observation about when her code ran, when she was doing sort of an intro programming course, and an error message came up. She took it very personally, that there was there was something wrong with her knowledge, and it was you can take that very personally. But she did observe other people just reflecting on, there's something wrong with my code, and fixing it, and that sounds like seems like a very important step for somebody to change their perception, and realize that an error message is not an insult on, directed upon yourself, but it's trying to help you.
Absolutely, yeah.
So it does seem like there's a wealth of opportunity there to help people pass that step. Absolutely.
I completely appreciate the concern that she must have been, having, and wondering, well, this is my fault. I'm the one that's caused this problem. It's not the fact that the computer doesn't understand what I'm trying to do. And, so looking at error messages specifically, they may not be the sole solution to that problem, but I think they can help. So one of the things that a group of us have looked at when we've been doing this error message research is what other people have said in the literature about error messages. And there's, decades of research where people are suggesting guidelines for how to construct error messages. And in fact, some of those guidelines might be able to address the concern that you've just mentioned. So one very common guideline for error message design is use a positive tone. And one of the ways to interpret that is to not blame the programmer for the mistake. And so it could be as simple as, instead of a message saying, you have forgotten a semicolon, to simply say, a semicolon is missing type thing. So it could be as simple as that. Those sort of cosmetic changes to the wording of the message might actually have an impact on the way that some people feel about that. But the one thing that really stood out to us looking at this body of research on error messages and error message design is that there were lots and lots of guidelines. So a lot of people were saying error message should be readable, they should not use too much jargon and so on, but almost no empirical evidence for those guidelines. So simply people saying, here is what I think here is the way that I think messages should be designed. And so, one sort of body of work that we've been looking at is, can we actually measure, if, for example, we construct a set of error messages that follow some guidelines, can we measure how much benefit that provides to students, let's say when they are trying to solve some programming task? Does it speed up their debugging time, and by how much? Does it reduce the number of errors they encounter? And so that's something that we've spent a bit of time looking at. And we've also looked at trying to bring together a lot of the design guidelines that we've seen in the literature, and sort of present them. So we ran a working group. Brett Becker and myself, Raymond Pettit was involved, James Prather was involved, and a number of other people were involved in that working group. That was an IDICE working group in 2019. And that working group essentially was a review of all of the literature on error messages. And a lot of that work was looking at presenting these guidelines. And really subsequent to that, we've started to do this work looking at, can we actually produce error messages that are better for novices, that allow them to solve problems more quickly, and so on. And so that's been quite interesting, and we've made some good progress there. And certainly there is some evidence that if you put a bit more thought into the design of the error messages, you can have a positive effect on the way that novices debug their programs and fix their errors.
So that sounds like it sounds like a very noble effort to improve the quality of the error messages. But I imagine there will always be an uphill struggle. There's so many interpreters and compilers out there that are unlikely to change. So I suppose at the other end of the spectrum is helping the student become more resilient to these error messages. I mean, that seems like almost like a useful activity of an introductory course, is just to inoculate them against the pain of error messages, or taking it too deeply, and understanding how to go about using them.
Yep, and I think you're right. And I think also where you're going with that is that at some point, students have to face the reality of the actual error messages that are produced by their system. Some of the work we've done, and the one I just mentioned, was really about taking the raw compiler error message and repackaging it and presenting it in a more readable and a useful way. And so, yeah, I think, we can shield students somewhat from the reality of the actual error messages, but at some point they do need to recognize what those are. And I don't think we really know yet the best way of doing that kind of adaptation, like, helping students through that process. But I'm fairly convinced that the right way isn't to just drop students in the deep end and, like, on day one, present them with messages that are, completely unhelpful and cryptic. And so I think there is some middle ground there where we can provide some scaffolding. That transition period might involve showing some of the kind of raw error messages alongside the more easy to read and easy to interpret messages at some point. But I think initially starting with just the easy messages that actually are helpful to students is a really good way to start.
I know that in some of our schools courses that we've written, we've captured when we've spotted that there is an error message and given some supporting information that is phrased nicely to sort of say, look, it's saying value error. What this means is this thing, and perhaps that is that scaffolding you mentioned.
And you, Bryn, I mean, at Grok, you must be uniquely set up to sort of study these types of problems. Have you, at least, or from what you've just described there, providing alongside the error message some other useful information, have you seen what happens if you don't do that? Like, prior to adding that feature, did you notice that students found it more difficult, or is it's not data you've looked at?
Well, it's more that the course has evolved, and so we've learned from previous experience that's been the sticking point. So it'd be interesting to do some A/B testing on that, perhaps, to pull it out. But yeah, and this is, I think, is always one of the challenges when you must feel this a lot of the times. Your prime focus is the teaching rather than the research a lot of the time, and so sometimes you just improve things because you know this is better. It takes that extra step to then go, shall I evaluate that so I can present it to the broader community. And I think that that's often a trade-off that a lot of interesting developments in education research, they don't really get reported in literature because there's a lot of us who are just trying to make our courses better without thinking about doing that side of things. So the other thing, the other area of research I know that you're active in is some motivation through gamification, which is, you know, gamification being a very hot topic. I see that in a lot of the literature every conference. And the underlying issue of motivation, I think, is a key one. I think a lot of the time we have many potential students who don't complete or don't even start in computing because of motivation issues. So I'm interested to hear where you're exploring in that.
Yeah, this also is a really interesting area to me, and you're right. It seems like it's become a very hot topic over the last few years. My interest, I think, again, relates a little bit to what I was talking about previously in terms of being able to access the data, this fine-grained data about student activity. And of course, we know that there are certain behaviors. Let's, for example, take Peerwise as a case study, right? So imagine an activity where students are crowdsourcing learning content for one another. So in this case, crowdsourcing these practice questions. We know that there are some behaviors that are beneficial to the learning of the individual student. So for example, we want students to practice answering questions. And in fact, I mentioned earlier the testing effect. There are certain ways that we can enhance the benefits of testing. And one of those ways is what's called spaced repetition, or instead of doing all of your practice in one block, you spread that out over time, over a period of days or weeks. So we know that there are these certain behaviors that are good for the individual, you know, like spaced repetition, like creating questions. We know that, you know, reflecting on the content you've been learning and constructing a question is a really good way to sort of reinforce your understanding of that area. We also know that there are certain behaviors that are kind of good for the system, if you like. So, for example, when students rate the quality of questions, that's very beneficial to the system because it means that other students can find the high quality questions or the highly rated questions. And so you can identify all of these different behaviors that are beneficial to the individual, behaviors that are beneficial to the system, and then think about how can we motivate students to actually engage in these behaviors that we know are good behaviors. Now, how can you do that? Well, one way that you can do it is using marks, because marks are a very, very good motivator for a lot of students. You know, I'm sure a lot of teachers are aware of the struggle of trying to get students to do something, and they say, well, how many marks is it worth? Or, you know, is this going to be on the final exam? And so, although marks are a pretty powerful motivator, they have some problems, right? There are a limited number of marks that we can distribute across all of our course activities. And actually, for the most part, I think you want marks to be a way of kind of measuring summative performance. And, you know, with an activity like Peerwise, which is primarily student driven, you're going to have to, like you did, Bryn, hire tutors to kind of grade the work students are doing, and that may not be the direction that you want to take. And so I think that's where something like gamification comes in. It's like, can we design within the interface of the tools certain rewards that incentivize students to engage in those behaviors that we know are useful to them and to the system? And so I think it's a very interesting idea, because, you know, it's a potentially relatively easy way to incentivize, you know, positive behaviors.
So what kind of rewards then do seem to work in that case?
Okay, so let me give you an example. One thing that I think we need to be careful about if we're looking at trying to gamify a system is we want to avoid a problem which is known as gaming the system. So, for example, we want to motivate certain behaviors, but we don't want to motivate the wrong behaviors, where maybe, let's say, students can earn points or something for doing a particular action. Unless that action is actually beneficial to them, we don't really want to be rewarding that. And so I think the types of rewards that work the best are the ones that are not easy to game in that sense. So let me give you an example. Let's say that we rewarded students with I don't know, points or something. They earned some points if they rated a question. And so what might happen then is a student can see that, I've answered this question. If I submit a rating, I get, 10 points. Well, they might suddenly become highly motivated to increase their score, but they don't really want to read through the question. So they just start rating things randomly. And the problem with that is they're not providing useful data to the system with these random ratings, and yet their score is increasing. So I think that sort of thing really needs to be avoided. And it's not easy to do that. But for example, one strategy that I've used in Peerwise to try to avoid that is to come up with rewards which are not easy for individual students to influence. Instead, they are only rewarded when other students in the system find the original individual's contributions useful in some sense. So let's run with this example of rating questions. Clearly, we want to motivate students to rate questions because we can then aggregate the ratings across the questions, and we can filter out the low quality questions from the high quality questions. And so one particular sort of game mechanic in Peerwise is a point system which records the reputation of a user. And so over time, this grows when someone provides useful information to the tool. And so one of the components of that overall reputation score is a measure of how useful the students' actions have been in rating questions. And the way this works is we actually want to motivate two things when it comes to rating questions. We want to encourage students to rate questions accurately, that is, give good quality questions high ratings and give low quality questions low ratings. But we also want to motivate students to rate questions early, because the earlier a student rates a question, the more other students in the course can benefit from that rating. So one of the ways that this works in the Peerwise system is that when a student gives a question a rating, they don't immediately get rewarded for submitting that rating. And so this helps to avoid the problem of this gaming behavior. Instead, when another student comes after the first student and gives the same question, the same rating that the original student gave it, then the original student is rewarded with some points. And this is quite a simple mechanic, but it motivates those two things of rating early and rating accurately. Because if, for example, you're the very last student to rate a question, you will not earn any points for that because there are no students that can come after you to do the rating. And likewise, if you give a question an inappropriate rating, let's say it's a really good question, but you give it a low rating, the students that come after you, who presumably are rating the question fairly, are not going to agree with your rating, so you won't pick up points for that. So I think one of the mindsets on how to create these reward systems is to reward behaviors that are actually useful to the system and avoid that sort of gaming behavior.
So what about coordinated gaming of the system then? Because that must be a risk then, that if a student is aware of that mechanism, they might sort of say, I've given this score to somebody, you give the same score, yeah, so I get the score.
I'm glad you've asked that question, and I don't have a good answer to it. I mean, there is only so much we can do. And actually, I sort of see this as, in some ways, similar to the challenge of plagiarism in a course, where there are certain things that you can do to try to, avoid that behavior. But, at the end of the day, it's extremely difficult to completely avoid it. I think one of the things that gamification has going for it is that, it's really designed to give just feedback to the student about what they're doing. And if it's not tied to the assessment of the course, there really isn't that much of an incentive for students to really engage in some large-scale coordinated effort, or to hire some third party like they often do with their assignments, to do the work for them. So it's a matter of sort of keeping the actual rewards, the real world rewards, actually low, I think, to disincentivize that. And for the most part, I think that works pretty well, but it's a difficult problem. When you solve the plagiarism problem, let me know, and maybe we can apply that to this.
Well, one of the things that I know is a classic sort of gamification device is a leaderboard, and you know, and then giving people visibility of where individuals are relative to others, and that promoting some level of competition that drives students to aspire to do better. But one of the things that I've also seen, and you know, in literature definitely, is that works well for the top 10%, perhaps, or yeah, whatever number of the students, but can be a huge demotivator for the rest of the students. And I suppose that sort of leads to when you have these tools, which students are you dealing with, and do different students respond differently to these gamification devices?
Yeah, I think you're right. And I've seen exactly the same thing in some of the data I've looked at, which is that, you know, across the entire class, you can see that the game elements actually have a very positive effect overall. But when you really dig into it, the reality is that it's a relatively small proportion of the students doing, you know, far more than other people. And yeah, that is a difficult problem. And on the one hand, as long as people aren't demotivated, and I think that's key, then it's not so much of a problem. I mean, if only a small fraction of people are really highly motivated, but nobody is demotivated, that's not really a problem. But I agree, it's a real problem if people are actually put off. And I can imagine, you know, the classic leaderboard design where, you know, you are at position 994, you know, out of 1,000 or whatever. Yeah, that could be really demotivating and might actually turn you off. So there has been in recent years a real push towards what's called tailored gamification, which is the idea that not every individual would receive the same gamification experience. And there are two common ways of doing this. One is called customization, and one is called adaptation. The difference being that with a customized gamification design, the individual makes deliberate choices about which gamification elements they want to see in the interface. So they can disable them, they can turn some of them on, they can turn some of them off, and so on. With adaptation, it isn't the individual that makes the choice, it's the system that makes the choice. And normally that choice is based upon, for example, something that the system learns about the individual, maybe some personality traits or something. And so with these adaptive systems, you might be presented with a questionnaire or a survey or something you submit, and then the system determines, this person's not going to be motivated by these highly individualistic rewards, but they might be motivated by these more collectivist rewards, that kind of thing. And so I have been looking we've been looking a little bit at the customization aspect. That is, can we, particularly for these students that might otherwise be demotivated, could we simply give them the choice to turn these things off so they don't see them? It's obviously a very simplistic solution, but it's worth exploring. And it's too early to really say anything definitive. But one thing that I found somewhat surprising, in fact, maybe, here you go, I'll put you on the spot, Bryn, I'm going to ask you a question, which is that in a typical cohort of first-year university students, if you give them the choice in a typical system, you know, would you like to completely disable all of the gamification elements and just have the plain system? Or would you like to enable all of the gamification elements and have the fully gamified experience? Can you hazard a guess as to what proportion of students would completely disable everything?
My guess would be that there would be, let me say 30% would choose not. That would be my guess.
Wow, you are incredibly accurate. So we actually found it was about a third, so just over 30%. Yeah, and to me that was somewhat surprising. Obviously not to you, but yeah, I thought it may have been a bit lower than that. But what we haven't really looked at is to test that. You kind of want to have a control group where kind of everybody is given the gamification, and you can then compare it to the people who can either choose to turn it on or off. And so I think that's sort of work in progress. But yep, one of the potential solutions is just to do this, allow this customization to take place. And I think there's also a lot of work looking at, are some types of elements more motivating to certain people with certain personality traits and others. And so that's another avenue for work as well, is just not giving everybody the same experience, but trying to provide these rewards that will incentivize individuals based on their personality.
I wonder about the other side of things, as well as sort of trying to make gamification work for different people. There's how long do you keep gamification going? Or at some stage, you want people to develop their own metacognitive skills, their self-efficacy for their own good, and make that sort of an intrinsic drive rather than because there are some sort of external rewards. Is there a good line that could be drawn in how far you take these things?
That's a very good question, and I think requires sort of work over a much longer time frame than I've typically been looking at these things. But I'm certainly aware of that criticism about potentially these extrinsic rewards, which these gain elements really are, might harm the intrinsic motivation that somebody has for a task. And sort of intrinsic motivation is the ideal type of motivation, where somebody wants to do something because they have an interest or an enjoyment in the task itself, and the gain elements are just something on top of that. And certainly, yeah, you don't want the situation where someone is only doing something so that they can increase their score. And it's an interesting question, and I think some of it can be addressed through the design of the gamification elements, because there is, so one of the big theories of motivation is self-determination theory, and it states that there are these several fundamental needs that people have in order to achieve personal growth. And so you've got the need for competence, and the need for autonomy, and the need for relatedness. And I think if we think about gamification elements and the sort of extrinsic versus intrinsic playoff, you can think about things like competence and autonomy. So people have this need for competence. They want to feel that they are developing mastery of skills and are able to achieve their desired goals. And then there's this feeling of autonomy, that is that people can make decisions about what they do. They have control over the decisions that they're making. And depending on how the gamification elements are designed, they could potentially harm autonomy and therefore decrease intrinsic motivation. And this could be the case if the game elements are perceived as controlling, right? So for example, maybe you've got game elements which maybe there's a countdown timer or something, or badges that require you to log in every single day. And it might be perceived by the individual as controlling their behavior. They don't really want to be controlled. And that sort of harms that feeling of autonomy. And therefore they might have lower intrinsic motivation as a result. On the other hand, if the way the rewards or the game elements are presented are in a way that provides information to the individual about their progress. So if someone can see that, okay, this particular topic, I've earned points there, I'm clearly increasing my ability to understand this material, that can potentially improve feelings of competence in that area, and therefore have a subsequent positive effect on intrinsic motivation. So there is that playoff, and I think it can certainly inform the way that game elements are designed. And we ideally want to be providing information about growing competence to users. But yeah, the idea of then like how, over a long period of time, at what point can we simply remove the gamification elements and allow people to rely on their intrinsic motivation for the task? That's an interesting area of work. And I know certainly people have looked at that. But I think there is a lot more work that could be done in that area.
It certainly is paints an interesting picture of just the space in which an educator, for instance, a lecturer, can work in terms of the amount of control they have over the journey a student might take in terms of how they feel, how they're motivated. It's clear that a lecturer has much more responsibilities beyond just delivering material. They are delivering a learning environment. It feels like there's actually an unsaid sort of code of ethics that perhaps needs to be followed in the same way as you know, a doctor might, you know, first do no harm. You know, first of all, don't put off most of your students, so also like that.
I think you're quite right, and I think primarily that burden of motivating students really does fall on the lecturer. And if we're talking about game elements within some particular tool, the effect there is going to be much less significant in comparison to what the lecturer might be able to do. And certainly I think that is, you know, the responsibility of the lecturer to get students enthusiastic and excited about the subject, and convey that excitement, and thus build motivation in their students.
Which is a huge responsibility, considering that a lot of lecturers have no training in that space. So that's a huge.
Absolutely. And perhaps, you know, you might be asked to teach a course that you're not that enthusiastic about. And so, you know, students are, you know, can, I think, detect, you know, genuine enthusiasm very, very well. And so, yeah, lots of challenges there for teachers.
Absolutely. Well, Paul, thank you very much. That's been a really fascinating tour through a wide variety of research interests, and it looks like you're scratching the surface of a lot of new areas. So it'd be very interesting to see where that goes.
Well, yeah, thank you again for the opportunity, Bryn. I've really enjoyed having the chance to talk about some of these things. And I want to know, do I get a badge for this or something?
Special Grok award. Yeah, exactly. It'll be in the mail soon.
Exactly. Brilliant. Brilliant. Yeah. Thanks very much, Bryn. I've really enjoyed it, and I look forward to keeping in touch.
Thank you.